Okay, so for the purple quiz, number one, using the information provided to write an equation in standard form of the hyperbola, given the vertices and foci. Just real quick sketch this guy to kind of see what's what. The vertices are at -1, -9, so -1, -9 like this, and -5, -9. Okay, so if that's the case, then this would be the transverse axis, and this would be a hyperbola that's opening to the right and left. Since it's going to the right and left, we know a lot of things. Number one, we can figure out where the center is because that's going to be halfway between the vertices. So the center is halfway between -1 and -5, which is -3, -9. We got that. We know that A is the distance from the center to the vertices. So from -3 to -5, that's 2. And from -3 to -1, that's also 2. A is 2. A squared equals 4. The distance from the focus to the center would be from -3 to 2 rad 10, or -3 to -2 rad 10. So C is 2 square root 10, meaning C squared is equal to 40. And B squared is A squared plus B squared, so 4 plus 36 equals 40. So we know where the center is. We know what A squared and B squared are. We can write the equation. So this is going to be the equation x minus h, so x minus -3 makes that plus 3 squared, over A squared, 4 minus y minus k, y minus -9 makes it y plus 9 squared, over 36 equals 1. And there's the equation of our hyperbola. This one, same type problem. It says use information provided, which is vertices and foci, to write the standard form of the hyperbola. Again, just for perspective, see where things are. So we have the vertices at 7, 15, and 7, -15. So then this is going to be the transverse axis, which means that the center is halfway between 15 and -15. So the center is at 7, 0. Okay, and the distance from the center to the vertex is A. So A is going to be 15. From 0 to 15, and 0 to -15 is 15. A squared is equal to 225. C is the distance from the center, 0, 0, to the focus. So that distance is the square root of 274, which means the square root of 274 squared is just 274. So we get C squared. And B squared is A squared plus B squared. So 225 plus something equals 274. So 225 plus 49 equals 274, and we have enough information to get the equation of our parabola. So this one is our hyperbola is opening up and down. So this is going to be y squared over a squared version. So y minus 0 squared, or just y squared, over a squared, 225, minus x minus 7 squared, that's the y coordinate of the center, over b squared, 49, equals 1. And there's our equation. So we're given the equation of the hyperbola, and we have to find the center, vertices, foci, and asymptotes of the hyperbola. Start with the center, because we get the center from the equation. Remember, the center is always hk, and this is of the form y minus k squared over a squared minus x minus h squared over b squared equals 1. So the center is going to be at -3, 1. So -3, 1, right about there. A squared is going to be equal to 16, which means A equals 4. B squared is equal to 4, meaning B equals 2. And c squared is a squared plus b squared, 20. C equals square root 20, which is between 4 and 5. So since this is a hyperbola opening up and down, and we know that because y squared is the positive version of it, the distance from the center to the vertex, or vertices, is going to be 4. So if we start at negative 3 and we move up 4, we get negative 3, 5 for one, and we get negative 3 for the other. So negative 3, 5, negative 3, negative 1. There's our vertices. Okay, the distance from the center to the co-vertices is 2. So we're going to go this way, 2 to the right 2, and to the left 2. And with that, we can draw our box, which is going to help us draw the asymptotes. Okay, so here and here are asymptotes. The ruler works so much better to draw straight lines. Okay, so what do we know? We're going through this point. Okay, so using the point slope form of the line, we're getting y minus the y coordinate of our point, which is the center, 1, is equal to a over b, because we're going from the center up to a and then over to b. So 4 over 2, which is 2x minus negative 3x plus 3. There's the equation of our asymptote for this positive one increasing from left to right. And for the other one, this guy, it's going to be y minus 1 is equal to negative x plus 3. There's our other asymptote. We know the hyperbola is going in that direction, so we just have to find the foci. Okay, so foci, the distance to the foci is c, so that's going to be starting at our center, negative 3. Remember, we're changing in the y direction, so that's going to be 1 plus the square root 20 to get to one focus up there, and negative 3, 1 minus square root 20 to get to the other focus. So we've got center, vertices, foci, asymptotes, and we're good. There you go. Okay, so this problem, number 4, is very similar to the previous one, only this time, since its x squared term is first, this is going to be a parabola that's open, or excuse me, a hyperbola that opens to the right and left. We start at the center. The center is given by the point 1, 1, because it's x minus h, x minus 1, squared, minus y minus k. So k is positive 1, so we get our center. A squared is the denominator under our positive fraction, so a squared is 15. A is equal to the square root of 15. B squared is equal to 5, so b is equal to the square root of 5. And c squared is equal to 20, so c is equal to the square root of 20. Don't worry about the radicals, we're just going to leave them as such. Don't worry about reducing them or getting decimal values, just leave them as radicals. All right, starting at the center, 1, 1. We're right here, correct? This is hyperbola that opens to the right and left, so the distance a to the vertex is going to be to the right and to the left of the center. So if we're starting at 1 and we're going square root of 15, which is almost 4, we're going to be out here, right? And 1 minus square root of 15, so it'll be over there. So this is 1, we're moving in the x direction, so plus radical 15, 1, and 1 minus radical 15, 1 for our vertices. Okay. B is the distance from the center up to the co-vertex, which we're going to use to draw the box. So square root of 5 is a little bigger than 2. So we're going here and we're going here. And I'm just estimating these. You're going to use graph paper and make it a little bit cuter, but that's okay for now. So we draw our asymptotes. We have to get the equations of the asymptotes. And again, we're not going to worry about the radicals. We're just going to leave them as is. Okay, so point slope formula, we're using this point, which is the center. So that's going to be y minus the y-coordinate of the point we have, which is 1, is equal to the slope. Remember, we're starting at the center. We're going up radical 5, and we're going to the right radical 15. We can just leave it as that. Radical 5 over radical 15. Don't worry about simplifying the radicals for now. We would do that later. And this is going to be x minus the x-coordinate of the vertex, which is that. So there's the 1 asymptote, for that's the positive one for the line increasing left to right. For decreasing, it's going to be everything's the same except the slope is negative. Okay, so we've got vertices, asymptotes, center. Now we need to find the foci. Foci, again, we're moving in which direction? We're moving in the x direction from 1. We're moving in the x direction plus square root of 20. So 1 plus square root of 20, 1, and 1 minus square root of 20, 1. So it's out there, roughly, and we get our hyperbola looking like that. So center, vertices, foci, asymptotes, and we're good. It's going to be... Okay, problem 5 is a parabola, so we need to find the equation given what's given. Well, we're given the vertex is at -2, +3, so the vertex is there, and the focus is at -1, 3. Okay, so if that's the case, we know that a parabola is always going to go through the vertex and around the focus. We have that. Okay, and this distance from the vertex to the focus is p. So the distance from -2 to -1 is +1. We use p in this equation, absolute value of a is equal to 1 over 4p, to figure out what our a value is, which is part of the equation. 1 over 4 times 1 is equal to 1/4. And since this is opening to the right, that's going to make it a is positive 1/4. Okay, so we're good to go, right? This is a parabola opening right and left, so that's going to be of this form. X minus h is equal to a times y minus k squared. That's the form. We know what the vertex is. So x minus -2, the x coordinate of the vertex, x minus -2 makes it x plus 2, is equal to the a value we found, 1/4, times y minus k, y minus 3 squared, very ugly too, squared, and we just got the equation of our parabola relatively quick. Okay, so for this guy, copy pasted in the wrong directions here. So for this guy, it says find the vertex, focus, axis of symmetry, and directrix of the parabola given by the equation x minus 2 is equal to 1/2 y plus 1 squared. Then graph and label the parabola. So we need to recognize first that this is a parabola that's going to open to the right or left because it's y squared. Since a, this value, is positive, this is a parabola that opens to the right. First thing we're going to find is the vertex. We get the vertex from the equation. So vertex is x minus h is 2, and y minus k, so y minus -1 makes it plus 1. So our vertex is at 2, -1. So here we go, 2, -1. There's our vertex. We know that this guy opens to the right because a is positive, so we already have our sketch, relative shape of the parabola. We have this equation, the absolute value of a is equal to 1 over 4p, where p is the distance from the vertex to the focus and vertex to the directrix. So we need to figure out what p is. We know a is 1/2. That's coming from the equation. There's a is equal to 1 over 4p. We also know that a is positive, so we don't have to worry about that. Cross multiply here. 4p equals 2. So p equals 2 over 4, which equals 1/2. So the distance from the vertex to the focus, which our parabola here is going to be to the right. There's our focus. The focus is going to be at the point 2 plus 1/2, so 2.5, negative 1. And the directrix is going to be that same distance, 1/2 to the left. So this is directrix. Directrix is going to be 2 minus 1/2. So directrix is going to be the line x equals 2 minus 1/2, which is 3/2 or 1.5. And the axis of symmetry is just the line that goes through the center of the parabola, through the vertex, through the focus, perpendicular to the directrix. So our axis of symmetry is the line y equals negative 1. And so relatively quickly, from looking at the equation and recognizing what the terms in the equation mean, we can get all the info for our parabola.